So the Keynote's a lot of fun because you have sort of a license to go out beyond the boundaries. And I'm not going to get up here and say this is what a blockchain is. This is the mechanics of it. We're going to talk about you. Frankly, this is product life cycle management. What about your life cycle? You're the ones who really make this stuff happen. Without you, I mean, if you want to borrow from I'll return the favor and talk about British politics, for example. Prince Philip once said, everything that was not invented by God herself was invented by engineers. And every time I tell that, I get the similar responses. That's me telling a Trump joke. I don't know why, but that's just the way it goes. So this is what we're talking about. Why is it important? Why must engineers take blockchain seriously? Engineers will be using this in much different way than finance and insurance. Right now, you're hearing finance and insurance are the big buzz out there, and there's a reason for that. But we've got a completely different use case, and it's staggering in its implications. And we just like to bring this forward as soon as we can so that we know what route do we take? What choices do you make when it comes to blockchain? So a brief history of the IABC, and I started this back in NAFTA. We are trying to create the mutual recognition document between engineers, between Mexico, United States, and Canada. And when you first go down to Mexico 25 years ago, the infrastructure was terrible, and you start asking yourself, well, the engineers must be completely ill-equipped. But I worked at the university, and I found the engineers extremely intelligent, and I sent them to the engineering board exams, and they performed extraordinarily well. And you have to ask yourself, well, what's the problem? Why is this? It turns out that the insurance industry was the problem. There's plenty of money, plenty of engineers, but there's holes and gaps in insurance. If you can't make a bet, you can't make a bet without odds. And you couldn't invest because there were holes in the insurance. That was a revelation. People didn't quite realize that could be the thing that's blocking a lot of tremendous development in the world. In 1997 to 2008, I was at Boeing. I was a customer engineer and a manager there, and we were working on the knowledge gap. You had a bunch of younger kids coming in, and you had a bunch of senior engineers going out, and 20 years of nothing. How do you get these two groups to talk to each other? Well, you create a market, and that was novel at the time. You create a market, and then they have an exchange. And then we founded a company called Social Flights, which was like the Uber of private jets. And if you know anything about aviation, it's such a regulated industry. There's so many variables, so many moving parts. You couldn't come up with a discrete solution, but you could approach it statistically and come up with a statistical likelihood that you would be able to fill these empty seats. So this taught us something else. And then the Ingenesis project was dealing with social currencies and time banking and things like that. This is just prior to the financial breakdown. And then, of course, comes blockchain. In 2015, we published the position paper for the National Society of Professional Engineers. That's 4 years ago with the FinTech Task Force. And we published a position paper on engineering for the National Association of Insurance Commissioners. We won a grand challenge contest for the American Society of Civil Engineers. Then we formed the Integrated Engineering Blockchain Consortium. We partnered with Blockhaus out of investments out of Zurich. And now Co-Engineers, we just released, is a blockchain that we built. It's a native blockchain that we built ourselves by engineers for engineers with what engineers need in mind. Okay, so one of the things we learned in NAFTA, I just mentioned, was there's this virtuous circle of economic development between banks, insurance companies, and finance. If a bank will not lend money unless the asset is insured. And an insurance company will not insure something unless it's properly engineered. And engineering requires financing to cover soft costs while it's being implemented. You know that right now with PLM. There's a lot of money that goes into it before it's actually kicking out revenue. All right, so that gap has to be covered by your CFO. So there's this virtuous circle, and if one of these pieces is missing, the whole thing falls apart. Okay, and this is what we learned in Mexico. So this is some of the ideas that we're carrying forward, and I want to introduce them early. If you look at engineering, engineers are basically invisible. Okay, a fireman, for example, has very little value until there's a fire. Then the fireman is worth millions of dollars per hour in saving property and lives, okay? So the value of the fireman is measured by the value of the fire. But if you have an engineer, a fire protection engineer out there, and the fire never happens, how do you measure the value of the engineer? And how is your value measured? You're all engineers, by the definition we use. How is your value measured? How do you predict innovation? How do you measure innovation? These things they don't exist. These are very important quantities that there's no way to measure them. Well, perhaps there is. In fact, this problem is so severe. Robert Solow, he's a Nobel laureate professor emeritus at MIT. He came up with this idea that, well, he studied it and he created a function which concluded or derived that he was studying the contribution of technological change and economic growth, and he estimated that 80% of economic growth was due to technological change, to innovation. Okay, an enormous part of the economy is created by you folks, okay? But this value is being incorrectly attributed to this old idea of land, labor, and capital. Okay, we're still kind of living in that world. Okay, so it's incorrectly assigned. And the problem is that innovation can't be measured directly. So what engineers actually do is they remove risk from systems. And this is what we all do. This is what you all do. Is you look at the supply chain. You look at where's the likelihood, where's the risk exposure, what can go wrong, okay? And then you determine the probability that peril is going to manifest. And then you assess the consequences should it manifest. And this is what we all do all day long. This is our microscopic function. And this is what we do. What if this were really easy to measure with blockchain technology? Something that you can't measure today can now be measured with blockchain technology. This is the position we're taking. And it's not a bad position because we know that value is measured into existence. The world did not begin with $233 trillion sitting in a box in the desert, 10,000 years ago. That's not how this economy started. All this money, all this value was measured into existence by the things that we make, and it's called the gross domestic product. And the classical factors of production are used. This is what they count in gross domestic product, the classical factors of production: land, labor, and capital. Well, back in Adam Smith's day and David Ricardo's day, it was easy to count these things, easy to measure these things. That's why they became the basis of the economy. It's simply they didn't have technology to measure anything more complicated. But we do now, today. So GDP today includes things like the babysitter, but it doesn't include motherhood. Okay, and I'm pretty certain that motherhood is responsible for every taxpayer that ever lived. Products, services, but not kindness and empathy. Yeah, you can't have a company without products, but you can't have a company without kindness and empathy. It doesn't work. Innovation, creativity, sustainability, safety, charity, social skills. If I go to the restaurant and I buy a sandwich, it goes to GDP. But if I make the sandwich myself, it doesn't go to GDP, whether I eat it or not. That's how arbitrary the creation of money is. It's kind of funny. So what if we could measure these intangibles, the social capital, the creative capital, intellectual capital that all of you deploy every day in enormous quantities for whatever you get in return? So this is in humans, not necessarily products. So we're measuring humans with the blockchain, not necessarily products. That's one of the distinctions we want to start moving into. Well, here's some fun facts. We can start talking about blockchain now. $100 worth of Bitcoin in 2010 is worth $7 million today. How'd that happen? The Bitcoin market cap is about $125 billion. Total cryptocurrency market cap is well over $250 billion. But 1,000 people own about 40% of the Bitcoin. So is that like a really decentralized? Does it sound really decentralized to you? Not really. So is it really meeting its goal? Más o menos. Okay, so fintech. VC-backed fintech in 2017 was $16.6 billion, these venture capitalists. And this is the finance side of the world, just going nuts trying to figure out how we're going to use this thing. And then the insurtech VC was $2.3 billion. That's a lot. But in engineering applications of blockchain from the VC community was very, very little, almost immeasurable. We're probably still one of the only purely engineering groups discussing blockchain. And it's pathetic, but there's hope, okay? There's hope on the horizon. Okay, so definition of blockchain, if you go to Wikipedia, you'll see this really interesting set of words. They all make sense individually, but okay. So blockchain is this decentralized, distributed, and public digital ledger that is used to record transactions across many computers that so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the collusion of the network. Nice working definition there. I mean, you guys know exactly what to do next, right? Well, you know, my definition is a little simpler. It's a clumsy little dance that the computer needs to do in order to simulate something that humans have been doing for thousands and thousands of years. And I've got this little robot here because the robot is, we kind of, invest our emotions in these machines. And this is kind of why there's a lot of hype, because we see something that kind of reminds us of ourselves, and we think, wow, we can extrapolate ourselves onto this thing. But the robot is not the best solution to this problem. An elevator is. Okay, but the elevator isn't sexy. Okay, but this robot, gets everybody excited. That's kind of what Bitcoin is happening with Bitcoin. So what problem does blockchain solve? Well, computers are really good at copying things, but they're not good at not copying things. So if I send you a contract, we both have, over email, we both have a valid contract, and I can change the terms, you can change the terms, and nobody knows which is the more valid contract. But this kind of goes back to the age-old handshake problem, and I'm going to ask Thomas if he'll give me a demonstration here. So imagine 1,500 years ago, you go to the market, and you've got chickens to trade for corn. Okay, so you would go to somebody, you don't necessarily know that individual, so you go up and you reach each other's hands, you grab each other's hands, I give you the chicken, I put it on the table, he puts the corn on the table, he inspects the chicken, I inspect the corn, everything's okay, we let go hands so he can't run away with both the chicken and the corn, because they can run faster than me. Okay, so this is the origin of the handshake, I think. I'm actually not certain about that, but it's a good story. But that's kind of what it does. It allows for that sort of behavior to occur. And this is brand new in finance. Finance has never had immutability. Oh, another thing about this is that transaction happened in front of a lot of people. So it would be very difficult for me to go back and go back on my agreement, because everybody here saw it. Now, I could, go back and steal my chicken back, but then I can't do that very often, because you all say, no, he's not good, and you kind of isolate me from the system. So there's a disincentive to corrupt behavior. That's the only point we're trying to make there. But this is brand new in finance and insurance. They've never had immutability. There's no transaction in finance which can't be reversed by a court of law, which can't be reversed by a lawsuit, which can't be reversed by regulation, or by even corruption. If somebody was to break the law and not get caught, they violated the immutability of that contract. Okay, so this is why finance and insurance is just going nuts, because they don't know what to do with this thing. It's something they've never seen before. But engineers, we've been dealing with immutability since the beginning of time. I mean, you can't unpour concrete. You can't return the wood to the forest. So we're wired for immutability. So it's really exciting for them. It's something brand new. But for us, it's really sort of like a superpower. Okay, it's just something that now amplifies our abilities, amplifies our skills. Am I pressing the right button? Okay, so there's two primary use cases for blockchain. One is this mechanization of transactions. You can call the back office. You can get rid of all those pesky brokers that want free stuff like healthcare and all that. Or you can use the blockchain to organize events with respect to time. Think of it like a giant metronome or a big clock, and everybody kind of throws all their events on the clock, and now you could see associations between events that are all synchronized in time, and it's like having a big data logger, so everybody could put different pieces of information. So I could see certain failures in the system happening here, but not there. And it's sort of like the CDC, for example, the disease place. They publish all the data about mortality data for humans. We could consider that lifecycle management, I suppose. And once they put all the data up there, it's almost a trivial problem to create an insurance product, because all the data, everybody shares the same data, and you can create an insurance product which levels out the cash flow. This is what insurance does. So that's the new to the world applications that we see for blockchain. Yeah, anybody can, nobody laments the demise of the typing pool. Yeah, I get it. And we all went to word processors, so mechanization is important. But this new way of thinking, this new organizing events with respect to time, that's the big money show. For more metaphors, if blockchain makes things information goes in one direction easily, but doesn't go backwards. So if you're a mechanical engineer, you can think of it like a check valve. You could have water, before the invention of the check valve, water only flew downhill. But now with a check valve, you can hold it. Okay, so now you have cities. You can bring water into a community, and the water doesn't flow back to the lake. You can bring water to the top of these skyscrapers because of the lowly check valve. So before check valve, no. After check valve, yes. This is the kind of metaphor that we're presenting for blockchains, the possibilities. If you're an electrical engineer, it's sort of like a diode. Before the diode, well, you can make a motor spin maybe and make a light bulb glow, but you can't do anything with computers. You can't create an integrated circuit. I mean, that's what semiconduction is all about. This fact that you've got this diode that checks the flow of the electricity going backwards. Now, think of the world before diode, think of the world after diode, and that's your analogy for application of a blockchain. If you're a systems engineer, this is the thing that secures the airport, the fact that you can't walk in the back door. Okay, that's what secures the airport. You don't need to have blockchain all over the airport. You just need one of these. Okay, and this is what it is. You walk through the thing, the door closes behind you before this one opens, so you can't go backwards. Okay, if you're a systems engineer, these tire puncture things, that's an analogy, a metaphor for application of a blockchain. PLM is an irreversible process. There's all these arrows and things going in all these directions, but to be able to check the flow from going backwards, is that useful? I mean, what points, what strategic points in a transaction, like the point where risk is converted from one person to another, from the owner to the manufacturer, from the contractor to the insurance company, all these transfers of ownership, you might want to put a check valve there. Okay, so these are very important tools, the way we're looking at to synchronize things with respect to time. So those are metaphors. Now we want to ask, what are these cryptocurrency thingies, okay? Well, a lot of blockchain applications, they don't have cryptocurrencies because they got these bad optics to it. You think Silk Road, you think, Foreign Corrupt Practices Act, different ways to transfer value under the table, not pay taxes. So they kind of got these negative connotations, but these cryptocurrencies are really, really useful for measuring stuff. It's like having, like breadcrumbs. You drop a token here, you drop a token here. You can measure the distance between the tokens. You can measure the velocity between those two events. You can measure stuff into existence. You can measure value into existence. The problem with cryptocurrencies is they're neither legal or illegal. They live in this extra legal sector because they're not property, because property needs to be associated with a title. There's rules regarding the divisibility of property, and the cryptocurrencies, they just don't fit into that legal mold, that legal construct. It's not money because the definition of money is pretty clear. It can only be issued by the sovereign government. But PEs, professional engineers, and I'm talking about licensed professional engineers, but the idea extends to all engineers. We have the ability to define property in the eyes of the law. So if there's a piece of land out there, the civil engineer will be the surveyor of the land. Once they stamp that drawing, you can now get a loan on it. You can now buy insurance. Before they stamped that product, it was just a pile of dirt. Or a building, it's just a pile of sticks until the engineer stamps the drawings. Now it becomes, you can get a permit, you can get the certificate of occupancy, you could cut it up into condos, you could do whatever you want. It's not until that transformational moment where the engineer witnesses the event, makes the claim, and now that brings into existence money, brings into existence wealth, it brings into existence value. So this is our superpower. We can do this. We can literally create new value. And individually, on an individual basis. And this is something that it's not well understood, and something that we're studying. Other than that, a cryptocurrency is nothing more than a state of energy. It's this little electron spinning it makes a nice picture. Okay, but that's all it is. And again, here's this cool graph again. Today, $12,000 per person on the earth is what we've measured into existence. So this is a chart I love. It's this is we're $233 trillion in debt. Okay, how'd this happen? Okay, the world owes itself almost 3 times more money than what exists. Well, what are we going to do about this? Well, there's 2 ways of managing this. Nobody seems to be too worried about it. You would think that we'd be running for the hills, but one of the ways they're doing it is they're measuring value differently. And to measure value differently, here's an example. You have these platforms. In the old days, the hierarchy, like a standard business, was measured by the expected rate of return, or something called CAPM, which had some market risk was associated with that. So that's the way you measured a company in the past. Today we've got these network platforms, and the equation is called Metcalfes formula, and it's approximately n squared. The number of people in the network squared is how you arrive at the value of that corporation. And we've got all these platforms arising now called Uber and Airbnb. I think Apple is like $1 trillion valuation. Amazon is like, what, $600 billion, and Facebook, $700 billion. These are astonishing numbers, just astonishing numbers. Where does this come from? But what they do is they're measuring the value of the people that they connect. Okay, they serve like a bridge. So Google and Facebook, it's the interactions between these people that are now valuing the company. So like a bridge, like the individuals they're coming together, their families are talking to each other, they have the soccer games they plan on Facebook, they have the LinkedIn, everybody gets to know each other on LinkedIn. So that's the value that they're now capturing and measuring into existence for their corporate valuation. So they create this bridge in between large bodies of people, and the value is calculated quite simply as the number of individuals squared. So if they can make a bridge, why can't we use a real bridge as a storage of value? So a country stores their value in 3 ways: gold, debt, and infrastructure. Everybody talks about gold and debt, right? Nobody talks about infrastructure. To use the infrastructure that we have to store value, to value the infrastructure against the social agreements that people make using the infrastructure. That could not have been done until blockchain. Okay, so this is enormous, and this is something that we do. Infrastructure includes your supply chain, includes the roads and the bridges and the highways that everybody uses to transfer parts, and the buildings and all the stuff that you all create. We can now store value in those things. Infrastructure is the platform on which everybody utterly depends. So if you're worried about generalized reciprocity of a token, for example, that represents infrastructure, it shouldn't be a problem because everybody needs infrastructure. Everybody can come to that agreement that this token represents this value, therefore it's tradable. So that's a huge opportunity. So what co-engineers did was we created a blockchain which is extremely simple. And what it does is it takes these claims and validations by engineers. So an engineer creates a claim on the blockchain, and it's registered on the blockchain. It's permanent. And then somebody comes along and validates that claim. Once the two are validated, then it becomes a permanent record. Okay, and that constitutes a asset. Okay, so those two people are married now on the blockchain, the claim and the validation. If you make a claim and you don't get a validation, that's fake news. Right? That's what a claim is. Without validation, so that's kind of a gate valve to fake news. Now, it's a game. Okay, the game incentives are different now because if I make a claim, the person who validates it, this is permanent, guys. You better know the person who you're validating. You can't be like LinkedIn, all clicking everybody's stuff. You got to know the person who you're dealing with. So that incentivizes meetings like this, where you all come together and know each other and get to know each other, talk about your work. Now you can validate each other and you can generate tokens doing exactly what you're doing here. Okay, so you make a claim, you get one token called the M token, which is like, remember, breadcrumb. And then if you validate a token, you get something called gravity. So there's mass, the M token, and G is gravity. Okay, so it's the ratio of these two tokens and how they behave which yields an enormous amount of information. Okay, so we can now track these interactions in a generalized way. So what happens is you would have your own transaction record, and then there will be this aggregated transaction record. That transaction record will have value. I'm going to go to this chart next. So this little round two here, that's your personal transaction record. It becomes your identification. You store your credentials, and it becomes your cryptographic key so that you can open certain doors based on your credentials and not open others. So maybe this individual has access to a nuclear power plant, and nobody else's can access because your transaction record doesn't have the right pieces in it. So this is how we could use these transaction records to anonymously and autonomously incentivize different circuits of information flow. Your credentials and your certifications, the mobility of your credentials is important. Instead of the HR department having to check your records and call your manager every time you change jobs, you've got this mobility of your credentials that's validated by other engineers and their credentials. And it's an autonomous, we call it anonymous until point of transaction. So nobody needs to know your name until you transact, obviously. But why do I have to tell you my name before we actually do business together? Once you do business, yes, you have to tell each other your name. But until then, you don't need somebody knowing your name. So you have these autonomous, anonymous identifications that allow you to transact in the system. So that's your personal credentials, and they're yours. Now the aggregate, all the decisions and all the data that you put into the database now becomes visible to banks and insurance companies. Remember, those are the people who are now looking for this data. They would have an incentive to purchase the mass tokens, which is going to give them access to the data. So that's kind of how we've created a market. Remember I told you at Boeing, this is what we did. We created a market between supply and demand for knowledge assets. Okay, so I'm going to pop back to here, this one here. So in essence, this is what we're saying. The claim and the validation become a material fact. That material fact goes on a blockchain, and now that material fact serves the finance, insurance, and engineering. The thing that they all share is risk. So they all share risk data. So this is the idea. And anything can be a claim, like a chain of custody, revision record, a peer review, test results, specifications, contingencies. Any instance where risk is converted from one person to another could go on this blockchain. So I want to keep it nice and simple. This is the last of the equations. Apologize, it's obligatory for engineers to do this. But the blockchain, we can bypass this old land, labor, and capital concept. That's consuming the world, it's consuming the energy, which is, it grows by consumption. And we can replace it with a different type of factor production, which is aggregate production function is a function of risk, insurance risk, and engineering risk. Okay, so now everything that we create now with the old factor production, we can now create with a new set of measurement tools. And why do we want to do this? Where we're at today is just an incredible place. You're right here. We're at the union between the digital twin and the physical sibling. Okay, there's a lot of people talking about physical twin. AI is one of these things. If you get garbage in AI, you're going to get terrible predictions out of AI. Your IoT, they're going to put 40 billion sensors all over everything. Who's going to design the sensors, install the sensors, maintain the sensors, calibrate the sensors, make sure those sensors aren't being triggered by some other event? I mean, this is an enormous problem. And we fantasize that this can happen tomorrow. It simply cannot. These are you have to validate the physical sibling to the digital twin. So that means that we need people on the ground. We need engineers to identify a situation and say, yes, this is as it needs to be, and then let that go to the digital twin. Okay, but you still need the engineers, and you need to decentralize those engineers. They need to be incorruptible. They need to be the right person at the right time with enormous efficiency in order to keep up with the velocity of this digital twin. So this is who you are. You're right in the middle here. And this is probably, maybe you feel this in the way your jobs are going right now, the work you're doing. You've got all these digital tools that are coming up and making these huge promises, but then you've got this physical universe that just doesn't seem to cooperate all the time. Well, this is what complex system integration is all about. So there's a very powerful tool now available to handle the physical sibling side. Okay, so we can now have the glories and the benefits of our digital twin. The call to action. We have the 10-5-5 project. We are looking for 10 engineering firms, 5 banks, and 5 insurance companies to be the inaugural stakeholders in the consortium, the IEBC. We've built the blockchain. We've got our governance model all set up. And the benefit is you get to learn how to build your own blockchain. These things are not rocket scientists. Well, unless you are a rocket scientist. Which many of us are, it's not a big deal. I mean, it's not too difficult. They make it sound difficult, but it doesn't have to be. Understand cryptocurrencies. Make them your friend. They are incredibly valuable. You can alter incentives with cryptocurrencies. You can do things. They're extremely valuable tools, and don't forget about them. And somebody tries to sell you a blockchain application without a token, it's because they want the token. They're going to take it, and it's extremely valuable. That's all. I mean, plenty of time for questions. We have, these are some of the organizations that have been helping us, we've been working with. Arup and ASCE and Jacobs has been a very strong helper and supporter of the project. The folks at NAFEMS, and let me plug the DE folks. They featured us in one of their magazines. It's been one heck of a ride. It's been a lot of fun, and we hope to hear your ideas and your questions going forward. Here is our disclaimer. Their attorneys say we have to have that. Are there any questions? We got several minutes left. Yes, sir.
Do you think the term blockchain is tainted because of cryptocurrencies?
Well, how tainted could it be? They're stealing terms from engineering. A block existed long before chains. That's our term. So they, if you look at things like hard forks, blocks, chains, roots. I mean, all these things that they're using, they had to take from our profession. I mean, because there's no other language. So yeah, the language is a little messed up. Cryptocurrencies, that kind of sounds a little weird. The cypherpunk movement, the libertarians are all into it. Yeah, there's a lot of baggage, but we have to look beyond that. I mean, we have to look at the machinery and how we can, how we can use it to our best advantage. Because if we don't do it, somebody's going to use it for us. Because we're the goose that lays the golden eggs. We're the engineers that create the value. Nothing happens until the engineers let it happen. So we have to, really have to take dominion over the whole thing in our speaking and in our approach to this. Yes.
This question revolves around this disrupting what we now know as our economy, our financial economy, or finance-based economy. So let's say the engineering value an engineer brings in from, say, India is different than, at least from the money standpoint, than an engineer that is born in Germany, maybe. And both have the capability to build or specify a bridge and build a bridge, but the financial compensation is different. But the blockchain is going to disrupt that. How do you see that as a conflict, or is that not even a concern?
This is our problem. Engineers have been segregated and divided by regulations, by political boundaries, by countries, by infrastructure, by digital have and have-nots. We're divided and conquered as a profession. Okay, but the laws of physics are identical in India as they are here. I mean, there's no difference. So why is this segregation in place? So if you remove that segregation, it's going to seek a new value. It's going to have more to do with proximity. What's the problem you're trying to solve? How many people are impacted? And again, remember that n squared. You're going to always be looking at how many people are impacted is going to determine the value. Like the firemen, they came at the right time to put out the fire. Their value goes to the roof. So if you have a problem like a big flooding issue in the typhoon, your ability to bring engineers at that point, at that time, has a lot of value, which is, So yes, the answer is yes. And the way we see it is as the economy diminishes under the weight of impossible debt, this is going to slowly increase. So we're just looking for, it's not like a redistribution of wealth or we're going to stick it to the man. None of that. It's just a different economy that we can all kind of shift over to while this one's kind of petering out. And then nothing has to really break. And we can just kind of continue on the way we are going. But absolutely, we determined the Mexican engineers were equally qualified as American engineers. This shocked everybody. We did it by the American examination. So yeah, a lot of differences are going to occur. I mean, it's hard to predict, but things are going to change.
I have a follow-up question,
sure.
too. How is the transaction that is, quote-unquote monetized or tokenized, as you were talking about, going to be different than how many likes you get on Facebook?
Well, likes are pretty trivial. Facebook is kind of, it's not just likes, it's like and absence of like. So when Facebook does their analysis, their graph theory, all these different connections, they look at likes and absence of likes. So there is, by not pressing like, you're making a decision, and they're recording that as well. In this thing, yeah, you could be really promiscuous, but is that wise? I mean, if you know, you validate an engineer and they turn out to be incompetent or an axe murderer or something like that, you know, you're kind of attached to that. And when they do the forensics, they're going to knock on your door and say, what do you know about this person? You know, the stakes are a lot higher. And you're now in the position to issue currency. So you're going to be you're going to be defending the system in your day-to-day actions, because it's in your best interest to defend the system than to let it get corrupted. But you're the guardian, so you have that choice. So the amount of that a mass token converts for $1, that's the market will decide. We are not going to peg. There's no pegs. There's no insinuation that we're going to replace any of this. It's just a marker. And humans generally have a tendency to create secondary markets for everything from, you know, tulip bulbs to you know, tally sticks. So if they create a secondary market for these things, fine. But that's not our intention. It's a peer-to-peer currency. It's a peer-to-peer unit. But that's kind of the way we're looking at the game, the math, and the calculus. Does that help a little bit? Any more questions?
Yeah, I have a question.
Yes.
When do you see this disrupting the legal industry from a patent perspective? And is the value ultimately the commercialization of the actual idea? Well,
the patents are really slow. They're really expensive. And only 60% of them are valid. And any other one can be kind of patented around or escaped. I mean, we've got a patent application, and I've used it more to defend against trolls, people who accuse me of stealing their IP. I just show them, look, I got this application, and it makes them go away. So the IP, like if I gave you the recipe for, say, Coca-Cola, what are you going to do with it? I mean, you know, you're never going to scale to Coca-Cola. You can't compete with Coca-Cola. So, you know, it's kind of a moot point. So it's not really intellectual. I can't patent, you know, a company can't patent what's in your mind. I mean, so the intellectual property issue is sort of moot. Yeah, keep your intellectual property. Certain things need to be protected, but in general, there's no constraints on what you can share with somebody else in terms of process or procedures or risk mitigation. There's no patent on risk mitigation. Yeah, so that's kind of, and again, if you have a patent, the thing you want to know is who's using it, when they're using it, and how much they're making off you. If you have a blockchain, well, these things are auditable. You could see, oh, this guy used my patent, here's where they're using it, and you could see that in the data. That's all you really want. So if somebody is taking your patent, you send them a bill. Yes, sir.
So let's say I'm like a guy in
They told me to wrap it up, but.
who'd like to put $100 in Bitcoin. As an engineer today, what would I do to get in at the $100 level?
Well, we have several. I'm getting a lot of zeros here. We're getting. We could talk about this offline, but there's by joining a professional association, for example, the National Society of Professional Engineers, and then when they give you when they stamp that you are a member of the NSPE or the IEEE or whatever these institutions, you will get tokens from them because they have a lot of gravity, because they have a lot of members. So it's a proof of stake. So by joining an organization, you start getting these tokens, and you can start trading with each other, individually with each other. But we don't sell tokens. The market buys the demand for tokens. So then you would take your tokens and sell them to the insurance companies on the exchange. That's how it works. But we could talk about this more. You go to our websites, ievc.co and coengineers.io. Those give you a lot more information there. Well, thank you so much. Thanks for enduring that.